Okay, so we'll be getting into the topic. Okay, so that is problems related to your bus admittance matrix. You'll be seeing. So the problem, first problem is we have already seen a problem with respect to the bus admittance matrix. How the formation of bus admittance matrix. If they are giving you the single line diagram, based upon the single line diagram, how you can form the bus admittance matrix, we have seen. And in today's problem, what we'll be seeing is if they are giving the line impedance, how you can find the bus admittance matrix. So we'll be dealing with that. So this is the problem. The line impedance of a three bus of a three bus power system of a three bus power system are given in the table. Okay, so the line impedances are given in the table. So it is needed to formulate the y bus matrix y bus matrix through inspection method. Through inspection method. Okay, so it will be getting into the table. So this is your table. So code. Okay, followed by your impedance. Okay, so from bus 1 to 2, it is 0.06 plus j 0.18. Okay, and from bus 1 to 3, it is 0.02 plus j 0.06. Okay, next from 2 to 3 is 0.04 plus j 0.12. Okay, so take down the table, we'll be getting into the solution. So okay, so in the previous problem they have given you the admittance matrix directly. So as per the algorithm, what it states, it is first necessary. It is first necessary to find whether the given data is a admittance or an impedance. Okay, so based upon that only we will be moving into the problem. So here,
So what are these bus codes? Bus codes and impedance.
so bus codes is nothing but it is a connection between one and two. For example, you can take this. So you just with the bus code itself, it is possible to draw your bus diagram. Okay, it is nothing but the connection between your first bus and the second bus. So the connection between the first bus and second bus. So the impedance value is 0.06 plus j 0.18. That is your Z12. So this is what they're saying. Okay, and from you can take this as a third bus, but they didn't give anything about the generator or the source. They have simply given you only the impedance value. So from 1 to 3, it is 0.02 plus j 0.06. Okay, and from 2 to 3, it is 0.04 plus j 0.1312. So this is the meaning of this table. Okay, so the table can be represented also represented through the single line diagram in this format. But here you cannot say this as a complete single line diagram, because here they didn't give about the information about the generator or the load. Okay, but they have given you the bus information. Okay, for understanding, you can draw this diagram. Okay, and we'll be getting into the solution. So as per the algorithm what I have stated, first you have to find whether it is impedance or admittance. So the given values are, we just write it, the given values are in impedance form. So they are not in admittance. Okay, impedance form. If it is in impedance form means, so in the previous problem we have dealt only with your real numbers. Okay, but over here we'll be dealing with your complex numbers. Okay, so the impedance over here is represented as z equal to x plus jy. Okay, and here what they have given, as per the given data, where z12 is 0.06 plus j 0.18. Okay, then comma your z13 is 0.02 plus j 0.06. Okay, so this is from the given data. Z23 is 0.04 plus j 0.12. Okay, so these are the given values, and from this will be what they have asked to find. They have asked to formulate your y bus matrix. Okay, they have asked to formulate your y bus matrix, and we'll be getting into it. So for this, the basic solution what we'll be doing is, uh, we'll be going with this. What we'll be doing is y equal to, you know that your admittance is the reciprocal of your impedance. So this I have already told with respect to your algorithm. The algorithm itself I have told. So your y equal to 1 by z. As per this, what you have to do is you have to take the conjugate, because this will be 1 by x. This will be 1 by x plus jy. So this is your z value. So in order to find the y value, you have to take conjugate with respect to the z. So if you're taking conjugate, means you'll be getting the y value. So how you'll be taking conjugate? You have to invert this sign and then multiply and divide your numerator and denominator. Okay. So what it becomes, 1 by x plus jy will be into, you know, to take conjugate, right? So that is x minus jy, and this will be x minus jy. Okay, and this will be coming at the numerator as such, x minus jy, but over here it is nothing but your formula for your a square minus b square equal to a minus b into a plus b. Okay, so this is the formula, and if you are doing that, here we will be getting x square plus y square. Okay, so based upon this only we will be finding y12, y13, y23, y11, y22, y33, all the other things. Okay, so first we will be getting with the small y1. Okay, we'll be converting all the impedances value into your admittance value. Okay, so y12, you can take it as an example. Y12 is equal to 1 by z12, which is equal to, can directly apply, you can directly invert the sign and apply, is 0.06 minus j 0.18. Okay, so you have just inverted it, divided by 0.06 the whole square. Okay, 0.06 the whole square. So here minus will be coming, right? A square minus b square, only a minus b into a plus b.
Sir, j square 1 minus 1, sir. So
Oh
minus
yeah,
and minus
yeah.
plus.
Okay, okay, fine, fine. So okay, you can also have that in your mind. So j square will be there. So it will be minus one square. So it will be getting plus. Okay, thanks, man. Thanks. So you'll be getting the plus 0.18. Okay. So we are taking the square for the complex value. So you'll be getting positive. Okay. So upon solving this, we'll be getting y12. And you give the value of y12. So your y12 will be, so solve it and you just tell me it. So your y12 will be, so use the calculator. Okay, use the calculator to find, it will be very much easy. Okay, minus 1.667 minus 5j, right? So you'll be getting the value to be 1.667 minus 5j. So this is the value of your y12. Okay, so it is the value of your y12. So moving on to your y13. So it is nothing but the reciprocal of your z13. Okay, so you can directly apply the value 0.02, okay, 0.02 minus j 0.06 divided by 0.02 the whole square plus 0.06 the whole square. Okay, so you just solve it and tell me the value of y13. So y13 will be, so use the calculator so it will be easy for you. So y13 value, okay, right. So it is around 5 minus 15j. So it's right. So we'll be getting 5 minus 15j. So it is your y13. So moving to y23. So it will be 1 by z23. And we'll be getting 0.04 minus j 0.12. And over here we'll be getting 0.04 the whole square plus 0.12 the whole square. So y23 value will be equal to So y23 value will be equal to also value. Okay, we'll be getting around 2.5 minus j 7.5. Okay, so we have got the value of y13, y12, y23. Okay, and now we'll be moving towards your y bus. Okay, how you can form your y bus and what are the elements of your y bus? So your y bus will be equal to so here the n is equal to 3, that is total number of buses. So hence you will be getting a 3 cross 3 matrix. So it will be y11 followed by y12 followed by y13, y21, y23, sorry, y31 and y22, y23, y32 followed by y33. So this is your 3 cross 3 matrix. Okay, that is bus admittance matrix. And from this we'll be finding all the values. That is your first you'll be starting with your diagonal or the self admittance elements. Self admittance you'll be seeing. After that we'll be dealing with the transfer admittance, self admittance, otherwise known as your diagonal elements. Diagonal elements. So first we'll be dealing with your y11. So what are the buses connected to your y11? It is very easy to say. So here you can see, so your first bus is connected with your second bus and your third bus. Okay, so these are the buses connected to your first bus. So the self admittance value will be, also they didn't give you the admittance, y11 admittance they didn't give, so you can consider only these two admittances. Okay, and hence the value will be, so your y11 will be equal to the connected buses y12, the admittance of connected buses y12 plus y13. So you'll be getting 1.667 minus 5j plus 5 minus 15j. Okay, so you have to add 5 with this. So basic addition, we'll be getting 6.667 and minus 20j. So this is with respect to either y11, and we have got y11. It's a self admittance. Now we'll be moving to y22, which is equal to y12. Here you can see. So for the second bus, which of the buses are attached, or which is first one is the first bus is attached and the third bus is attached. Hence the value will be y12 plus y23. So you'll be getting around 1.667 minus 5j plus 2.5 minus 7.5j. So basic addition. So you'll be getting 4.167 minus 12.5j. Okay. So after this, we'll be moving to y33. It will be y13 plus y23. So it will be equal to 5 minus 15j plus again the same thing 2.5 minus 7.5j. So here we'll be getting around 7.5 minus 20, yeah, minus 22.5j. Okay, so now we have got your diagonal elements. So now we will be moving towards your transfer admittance, or otherwise known as your off diagonal elements. So transfer admittance, okay, otherwise known as off diagonal elements. Okay, so here what you had, as per the formula or the algorithm, yij will be equal to minus of y ij. Okay, so you have to add a minus with it. So for with respect to that, your y12 will be equal to minus of y12. So you'll be getting minus 1.667 plus 5j. After that, y13 will be equal to minus y13 will be minus 5 plus 15j. Okay, as it is symmetrical, this y12 will be same as that of your y21, and your y13 will be same as that of your y31. And finally y23 will be equal to minus y23, which is equal to minus of 2.5 plus 7.5j. So this is same as that of your y32 because it is symmetrical. Okay, so these are your off diagonal elements, you have to see through it. Okay, and now you have got your diagonal, that is your self admittance, and your transfer admittance value you have got, and now you can form your y bus. So your y bus is y bus 3 cross 3 is equal to, and just write it, 6.667 minus 20j. Here it will be minus 1.667 plus 5j, and over here it will be minus 5 plus 15j. Over here it will be minus 1.667 plus 5j. Here it will be 4.167 minus 12.5j. It will be minus 2.5 plus 7.5j. It will be minus 5 plus 15j. The minus 2.5 plus 7.5j. Here it will be 7.5 minus 22.5j. So this is how you'll be forming the Y bus matrix if they are giving you the bus impedance. Okay, and another one part is that and when you're moving towards your second unit and load flow analysis and all, it is mandatory to form this Y bus. So you just keep on practicing and to solve, that is for forming your Y bus. Upon seeing the bus impedance value itself, you have to uh, form your Y bus matrix. So it is only possible if you are practicing the problems related to this Y bus matrix. So for more problems, you can just refer to that notes that I have given. Okay, posted in a Google Classroom. So there are numerous examples with respect to the formation of your Y bus and Z bus matrix. And I'll be just moving to the last model of the formation of your Y bus. Okay, that is, it's very simple. It is continuation of this problem only. You can see through it. So the problem is that is, you can have this. Consider the data. Consider the data. So this problem you are only going to do by yourself. Okay, data of the previous problem. Okay, so that is its continuation of the previous problem. Okay, along with along with so here they have given along with the following data. It is so bus 1, 2, followed by a third bus, and over here it is offline charge admittance. So they have given the value of offline charge admittance. So it is nothing but your y shunt by 2 value. So they have given the value. So I have already told, that is whenever you are considering your medium transmission line and your longer transmission line, you have to consider the factor of your y shunt by 2. Okay, because most of the line will be of a pi type model, will be in a pi type model. So in the pi type model you have to consider your y shunt by 2 value, this value you have to consider. Okay, so that too you have to consider mainly at your what you can say, mainly at your self admittance parameter, that is with your respect to your diagonal parameter you have to consider. Okay, if considering with your diagonal parameter means I have already told how the formula changes. Okay, it is very simple. Only that this y shunt by 2 parameter will get summed up with your diagonal elements. Okay, so what happened is that uh, the value of your diagonal elements of the uh, bus matrix alone changes. That is this value, this diagonal elements value alone gets changes in case of your they are giving the y shunt by 2 value. Okay, so what happens, I'll be just writing the solution, you just use the formula. So here y11 will be equal to y12 plus y13 plus y shunt by 2, and you have to see they have given you the offline charge admittance. So in the problem they won't be giving this y shunt by 2, they won't be giving. For the reference only for yourself I have given this y shunt by 2. Okay, what they'll be giving is they will be simply giving the offline charge admittance value they'll be giving. So then you have to consider this to be y shunt by 2. Okay, and here it is you are putting y shunt by 2. Okay, that is this y shunt by 2 you should not again divide by 2. What is the value they have given, the same value you have to put over here. Okay, that is for the first bus here they have given j 0.05, and hence here you have to consider this to be j 0.05. Okay, that is you have to consider this entire value to be j 0.05. You shouldn't divide this j 0.05 by 2 to make it clear. Okay, so you just find the value of y11 and y12, it is equal to the same y12 plus y23 plus, so it will be y shunt 1 with corresponding to a first bus. So this will be y shunt 2 by 2 corresponding to a second bus. Okay, tell me the values. You're simply going to add this factor only you're going to add. Okay, next year y13 will be equal to 7 sorry, it will be equal to y13 plus y23 plus y shunt 3 by 2.
Sir, 3 3 then sir. Why 3
uh,
3 then sir?
yeah, it's y33, y33. So what's the value you'll be getting for y11, y1 y22, sorry, it's y22, y11, y22, y23, what you'll be getting? So I11, what's the value? Okay, so for y11 you'll be getting 6.667 minus 19 point. So there it was 20, right? So 0.05 had to subtract it. That is, you have to add it. So it will become minus 19.995J. Okay. And coming to y22, it will be 4.167, 4.1 will be 4.167 minus 12.44 J. Okay, so this is with respect to y22, and with respect to y33 it will be 7.5 minus 22.45 J. Now your y bus 3 cross 3 matrix will be equal to, the diagonal elements alone gets varied, so it will be 6.667 minus 19.95 J. Over here it will be 4.167 minus 12.44 J, and over here it will be 7.5 minus 22.45 J, and the off diagonal elements or the transfer admittance remains the same, minus 1.667 plus 5J. Here it will be minus 5 plus 15J. Here it will be minus 1.667 plus 5J minus 5 plus 15J minus 2.5 plus 7.5J, and also the same minus 2.5 plus 7.5J. So this is what with respect to the problem if they are giving you the Y shunt admittance. Okay. So we have covered three models with respect to your Y bus admittance matrix. So the same is applicable for your impedance also. Okay, if they give you the impedance, how you can find means the same formulation what we have used for your admittance matrix. Yet I will be covering some Z bus problems and the algorithm for formation of your Z bus also in the upcoming classes, and I hope within few classes will be completing your first unit. So your first unit is primarily of your formation of your Y bus, Z bus, and your per unit problem. Okay, so that's what with respect to it.